So I guess I need to collect this. Assignment is due today, right? I hope you guys had fun with your assignment. No? Yes? Was it okay? I didn't expect to finish. I didn't expect everyone to finish the assignment. If you get around half of it, I guess that will be reasonable. So don't worry too much about it. Just if you do your best, if you did your best, then I'll be happy with that. So I will take a look at your assignment, and I probably select few ones with the good ones, and see. If the others are okay, then I will put those stuff on the 한양인, so everyone can take a look at it. So, and that's my plan for this programming assignment. And I uploaded another small assignment yesterday. So anybody take a look at it yet? Assignment 뭐지? Assignment 3. Yeah, assignment 3. It's also a very short assignment, small assignment. It's not much of a programming assignment. So if your Python program take a day, this one take probably less than an hour to finish. 얼마나 걸렸어요? How long does it take you to finish that assignment 2.1? Python programming one, maze one. How long does it take you? Very long. But the exam was easy. Midterm was easy. 그지? 중간고사는 쉬웠잖아. 그죠? 중간고사 아직 I haven't finished marking them all yet, but it was much easier than other midterms. Hopefully you will do also good on your final exam as well. Okay, I forgot. When everyone is here, I try to go over the assignment 3. Our assignment 3, yes. So I'd like to go over what we discussed last class. So we start discussing on something called Dijkstra's algorithm. What was the problem this algorithm try to solve? What was this problem? This was a pseudocode for solving the single source shortest path finding problem. 그죠? No? Yes? I hope everyone do remember some of the part of the Dijkstra's algorithm. It was well used for finding paths between 2 points. Of course, this particular algorithm is going to find all paths from a source to every other node in the graph. Graph referring to something like this, right? We all remember that. What was some of the preconditions that in order this algorithm to apply? What was some of the conditions that they say? Assumptions you have to meet. 시험 끝났고 한 며칠 노니까 그냥 다 백지 상태로 갔죠. 그죠? 그럴 것 같아서 리뷰를 잠깐 하고. I think a few conditions were like graph can be directed or undirected. It's going to work on both type of graph. 그죠? Also, they also ask you one more conditions like the weight on top of edges should be positive. No, everything has to be non-negative values for the weight. And we saw the reasons why it has to have a non-negative values for the weight and stuff. So what was the basic idea for doing this? 어떻게 했어요? So you pick the source node. From the source node, you find out all the neighbors that it can be reached from this source. And then, so there must be setup node that you can go to from source S. They call it as a S. So from the list of neighbors that you can go to, you select which one first. So among the neighbors, what would you select first? minimum weight, minimum cost first, right? If source S2 it has passed to 3 other nodes, you select the minimum cost among those 3, and then you include that node as a discover node. So you add that to that empty vector, empty list. And then having that value, you're gonna find out the neighbors of the neighbor. So the node that you can go to after that point. You also select the minimum of that node. You include that as a part of the discovered node. You continue that way until every node has a minimum values in it. That's why they put everything at the beginning as an infinity, large value. So that's why you have to put everything as an infinite, and then you start selecting the minimum values among that. You continue that way until you cover all the nodes in the graph. That was the idea for this, implementing this shortest path algorithm, this extra. And then we take a look at these examples. I'm gonna give you another set of examples, which is slide 8.2, which has a almost similar graph, but the pseudocode is the implementation is slightly different. So you don't have to just follow this way. Implementation can be different. We also saw that the time complexity of running this algorithm was what? If you don't care too much about efficiency, if you try to express the time complexity in terms of big O, 뭐니? It's close to what? N square, 그죠? Number of edges times number of vertices, number of nodes. Or they said you can depends on which implementation they use. You can do close to n log n, which is smaller than n square. That was also mentioned briefly in the last set of slides. So I'm gonna go to another set of examples for today. Yeah. And then I also mentioned that it's in order to prove that this extra algorithm actually work or not, means that it would always give a correct responses to the problem. Has to go through quite difficult proof, but we just simply discuss the basic idea of proving this algorithm. It's gonna use a triangular inequalities properties. What were the triangular inequality properties that I briefly mentioned in the board? You don't have to understand the formal proof, but what was the basic idea for this? Triangular inequality가 뭐였지? 왜 질문을 할 이유가 없구나. 그죠? 뭐 이렇게 해갖고. Remember, right? The distance between A and C should be always less than distance AB plus BC. But sometimes that property doesn't hold, especially the environment, the graph that you go to, right? Sometimes this shortcut is not the shortest one. So we have to go through that everything. And the second lemma was the part of the shortest path always the shortest path, which is quite natural to assume if you take a look at the pseudocode, because every single time when you find the shortest path, this was the part of the shortest path. Anyways. And then they give you a few examples on how to use the Dijkstra's algorithm, usually mapping applications, try to find the shortest path between 2 points from building 1 to building B. Which road you had to take is the minimum distance or the minimum time it requires to get there. So the Dijkstra algorithm is highly used in those situations. By the way, if you really wanted to test this Dijkstra's algorithm, you don't have to implement on yourself. You can certainly download the implementation from the web. There are a bunch of different type of implementation that you can try. So if you're interested, you can certainly try to look for a sample code out there, and you can try with the fake data sets and stuff. So, I'm pretty sure no one actually looked at this proof anyways, so I'm gonna skip it. So this was the stuff that we discussed last week, and I just wanted to give you a second set of examples just to make sure that we all understand what this does. Another set of examples. This almost similar. It's nice. It's what type of graph is this? This seems to be a directed graph. It has a direction too. It has arrow in it too, right? 2 to 3. So it's a unidirectional graph. And on top of every edges, it has a weight in it, 24, 18 to 30. So what if I ask you to apply the pseudocode with your own hands, get me the shortest path from source node S to every other node in this graph? Will you be able to do it? If I give you a table, I hope that you are capable of filling in all those blanks in the table. So last line of that table probably give you the shortest path of every other node. So how would you start? Just like what I just described a few minutes ago, you just try to find a minimum among the first set of neighbors. So from set S, initial group of node probably empty, start including as an S as a starting point. 그죠? This set of node is empty list, this containing the rest of the node. Okay, so probably node will be moving from here to that list. Okay, from that, I'm gonna set everything as infinite. 그죠? Infinite on top of here means distance from S to 2, initially infinite, a large number. So S to 6, infinite. S to 7, infinite. Reasonable. That's the same step that we all did, right? Just difference was we did it in the beginning of the pseudocode in the previous slide. 그지? And then what would you do next? 이제 뭐 해야 돼? 골라요. Which one to choose? It simply says delete the mean. D-E-L-M-I-N. Delete the minimum, it says. So maybe you could write a function to find the minimum among how many neighbors does S have at this point? How many neighbors? Directly from 2, 6, 7. 그죠? That's the reachable node from S. And among those 3, I like to delete the minimum. What's the minimum? 9, 14, 15? It's a kindergarten question, but 모르면 큰일 나지, 그죠? 모르면 답 없어요. So 9 probably the minimum value. It's exactly the same step that in the previous slide, but that slide was showing in the table manner. This one actually on top of graph. Okay, so delete the key. I know that among this this will be the minimum value among the 3, 9. So I changed the infinite value to 9. And then I'm gonna extend that, the shade is just simply indicating what node that I have been discovered. So it will be including 2 as a part of the discovered node. So S now containing source node and 2. After this point, it's pretty much the same thing. Reachable node, probably number of reachable node now increased because you now include a 2 as well. So I can go from 2, this, and this, right? So probably I need to compare to what? 24, 14, 7? 이렇게 되나? 그죠? After I set that as among 33. 그죠? Delete the mean, 14. 33, 14, 15. 14 is the smallest one. So now you're going to like this. You continue to do this until what? The shade covers all the node in the graph. 그죠? Next shortest one is probably here. Next one is there. Notice that you keep deleting the minimum one because every single time you discover a node, this value may decrease. 그죠? Because you find another path to get here. Whatever that comes the minimum, well, we're going to change to that. Delete the mean, blah, blah, blah. Over and over again, delete the mean. 이렇게만 해도 벌써 헷갈리기 시작하는데? 그죠? It seems to be simpler because the solution is given to you. If I give this graph without too much explanation, you're going to probably do some very funny things. You're probably finding a maximum node instead of minimum node. 눈으로만 봐서는 되게 쉬워 보이는데 손으로 꼭 한번 해봐요. This is very simple, not simple, but the graph is good to work on. I can give you some weird graph. Or there could be what if I ask you to find the minimum path among the graph like this? 이렇게 하면 뭐 다 됐나? 이렇게 하면 어떻게 할 거야? You can still do it, but it's going to require a lot of computation. Every single time you have to compute every other possibilities. So just pray that I hope, I'm not going to ask you this in the final exams, but I can always make it a bit tricky in a way to do this. 야, 이렇게만 해도 벌써 짜증이 확 나네. 매번 소스에서 막. 그렇죠? So later, the ones that you discover at the shortest path, they put it as a bold line. So this will be the minimum path that you can go to. After this point, what if I delete this normal edges? If I have that graph, new graph, if I delete the normal edges, then I still have a path to every other node. This seems like the minimum cover. With this edges, you can cover all the nodes in the graph. It's another property that you can take a look at it after this point. 그죠? 쓸데없는 거 이거 지워버려. 쓸데없는 건 아니지만 예를 들어 여기서 골라진 것만 딱 놔두고 나머지 거 쭉쭉 지우면 갈 수 있죠. 끊기진 않죠. 어디서든지 어디는 갈 수 있죠. S에서 어디든지 갈 수 있죠. Maybe you can use this Dijkstra's algorithm to find the maybe minimum path. I mean, least number of edges that connect all the graph. So that's another interesting property that you can certainly looking for. We're not going to cover that property, but it's something called cover problems. Or 뭐 여러 가지 이름으로 부르긴 하는데 나는 뭐 maximum cover, minimum cover problems. So what if I ask you to come up with the pseudocode to find the cover, minimum cover of this graph? Hopefully you can modify some of this Dijkstra's to come up with it, right? But what was the problem of the Dijkstra's algorithm? It was high overhead. So if imagine that this graph always change. Maybe this value always change from time to time. Maybe every 5 minutes this value change. Then I like to find out the shortest path every single time. It means I have to run it over and over again. That's very high computation. This is just what? 8 node. Imagine that you try to compute that every single time for 1,000 node. Right? It's not going to be. It's going to require very high going to require high computation and you're gonna have to wait a bit longer than expected. 그죠? Okay, this is what I wanted to just show you to remind you the things that we discussed last week. And I found an interesting figure. 뭐 figure는 아니고 when I was looking up the Wikipedia for this Dijkstra's algorithm 여기 어디 있었는데 찾아놨는데 여기 있다. Wiki actually is much better than my explanation. 나 이게 좋더라고요. This is animation of finding the shortest path from one of the node to this node. This is how they actually grow. I just simply explained what we just saw from the figure. It's way of growing that the shade to cover all the node in the graph. 좋다. 이걸 숙제를 낼 걸 그랬어요. 이렇게 만들어. 뭐 똑같지. 생각해봐. If you think about it, it's pretty much the same. I mean, I'm not asking you to implement your own. 됐지? As soon as you reach that node, 아이고. You just saw the shortest path given. Illustration of Dijkstra's algorithm searching for finding the path from start node to the destination. Hopefully, 뭐 이런 거 멋있지 않니? So, anyway, if you're interested, you can certainly take a look at this page. I'm sure they also provide some of the source code. They provide the pseudocode style. 이거 뭐 it's pretty much the same thing as the pseudocode that we saw from the slide, but this one actually suggests you use a HIP to implement this. Different type of implementation. This one asks you to use a priority queue, which we didn't cover yet. Different type of 구현하는데 different type of implementation techniques. You can certainly take a look. You can download. You can certainly use it. Okay. Any other questions on that Dijkstra algorithm? Anyway, I need, since everyone is not here, but I'm just gonna go over anyways. I'm gonna go over the assignment briefly. Assignment 3, like I said. Ta-da! Very short assignment, but I also give you 2 weeks to finish. So, but like I say, it's not going to take that long. Only going to require maybe less than a day. Couple of hours, you'll be done. Some of you already have the website anyways. So if you do, your job is much less to do. Anyway, I am going to ask you to build your own website, but not just website. I wish that you can integrate some of the Facebook plugins APIs. APIs it's some of the tools, functions that you can use from the web. So if you walk around the website, then some websites do provide the login functionality of a Facebook, or someone else's website, they can click on the like buttons right away. So how to integrate that into your web page? How many of you have a web page already? 그런 거 말고 T-Story 블로그 이런 거 말고. Anyway, how many of you have a web page? 없어? Raise your hand if you do have a web page. 아무도 없어 진짜? 홈페이지, 웹페이지라고 그러면 몰라. 홈페이지. 야, 니네 진짜 21세기에 사는 사람 맞아요? 어? 진짜야? 아무도 없어요? 이만한 사람 중에? Okay, hopefully then this is your opportunity to make one. It's not going to take that long. So you will create a website, integrate Facebook APIs. If you do have more time, then I hope you can integrate some of the Facebook games as well. You can use some of the APIs, build your own games for the Facebook platform. Anyways, so your website will be display some of the basic functions of the Facebook. So this assignment will help you understanding some of the HTML or JavaScript of doing it. So it's not C, it's not Java, but it's some of the very simple script to have your web page ready. I'm surprised that none of you have the web page. Everyone has a Facebook account, right? Facebook은 다 있죠? 그죠? So this assignment will help you understanding HTML, JavaScript, programming, web, social network services, SNS. So step 1 is build your own web page. If you choose to build your own web server, that's great. Which means if you have an extra server, extra PCs to run around, or if you're gonna use your VirtualBox to create, install Linux and install on top of Linux, you can install your own Apache, MySQL. That would be great. That it would be better than ever. But not everyone is familiar with that environment. So if you choose to do so, you don't have to build your own web server, but you can freely register to the website services, internet blog, cafe. There are free hostings that you can find. Google also provide the free hostings as well. Find one, sign in, get your space for your website. You may need to sign up for Facebook if you don't have it already. I'm pretty sure everyone has nowadays. Anyways, so step 1 is build your own web page. Just make it pretty. Put your pictures on, I don't know, whatever you want to do, make it pretty. Step 2, you will integrate the Facebook plugins that will consist of roughly 4 social plugins like Facebook login, likeness, also graph API provided by Facebook, and game, but that's optional. That's optional. I haven't done it either. So if you go into this website, developersfacebook.guideweb, you can just follow the step from A to D. You can just simply go and type it up. And step 3, you must make a unique design of your website. If you're having trouble to come up with your own, then just copy some of the nice looking website. If you're a designer, then you can do. For that, you can certainly take a look at some of the samples on the Facebook webpage. Okay, so these are the 2 URLs that you can take a look at. Step 1, 2, probably good enough. And step 3, hopefully everyone did make it good. So what to submit for this assignment is this. Update your website URL by accessing the following documents. If you copy this link, you will see something like this. And if you can print out your web page and print out the HTML version of your website, but only the part that you have developed, only the part that you have coded yourself. Okay, do not copy the platforms that you copy someone else's. Okay, the special functions, special JavaScript functions that you wrote, if you wanted to brag about it, print out and submit it. So your HTML version, HTML source files, but don't print. Last time I asked a similar assignment, some people print out the entire HTML, so they print out 10, 20 pages long. No. I just wanted to see the part that you only developed. Okay, so sure, maximum 2 pages only. Make it smaller font. Do not give me 20 pages long submissions. I'm gonna take a look at your assignment, your web page anyways through this Google URL. Okay, so this is what I asked for. So if you're not familiar with it, try to talk to each other. It's not a strong programming assignment. Previous assignment was a programming, so I don't care if you copy each other too much. As long as you have all the functions that I ask you to do, then it'll be okay. Talk to each other. Okay, any questions on the assignment 3? 질문 혹시? Okay, now we can get back to our textbook. I forgot which chapter this is. Which is chapter what? 이거 챕터 몇이에요? It's 7? 7인가요? 8인가요? 7이죠? 7. Okay, this is chapter 7 on your textbook, which is about some of the network internet related technologies, which some of you know already because we're using this every single day, but we never wonder how those things are possible. So they're going to discuss briefly on the protocols. What does it mean to have a protocol? Do we all know what is a protocol? 프로토콜이 뭐지? 프로토콜. 7이에요, 8이에요? 나 잊어버렸어요. 7 아니에요? 인터넷 관련된 거. 뭐 상관없습니다만 7인지 8 내가 잊어버려서 물어봤어요. 7 맞지 않아요? 네, 7 맞죠. 8은 다른 거 아닌가 싶은데? 네. 그죠? So we're gonna discuss stuff that we know, protocols. You guys are using it every single day, but you never call it as a protocol. Simply means as things like HTTP. Website. When you try to go into some website, just type http.www, right? HTTP is actually a protocol name, Hypertext Transfer Protocol. So it's a message format to communicate between two different entities. So you actually ask for information from a server, neighbor.com. So you need to make a HTTP protocol messages in order to communicate with the neighbor.com servers. So whether you like it or not, you are using it every single day anyways. So we're going to take a look at some of the basic ideas for the protocols. So this chapter describe, compare different networking technologies, including dial-up, broadband, and wireless. I don't think your generation used a modem. 여러분들도 모뎀 세대인가? 그렇지 않죠? 썼어요? 진짜? 모뎀 언제부터 스피드 뭐 때부터 썼는지 혹시 기억나요? 1000? 아 하이텔 여러분들 하이텔도 썼어요? 그 시대가 아닌데?
그건 안 쓴 것 같아요.
하이텔은 날 때 텐데 모르겠다. 뭐 하이텔 쓸 수도 있지. 최근은 없죠. 하이텔 없어졌죠. 네, 아마 없어졌. 천리안 뭐 하이텔 옛날에 있었는데 아마 이제 서비스가 종료됐을 거예요. So dial-up modems. What is dial-up modems? Broadband. You are more into broadband. 뭐 DSLs. 요즘에 뭐라 그래? 뭐 I don't know. FTTH, fibers. What do those means? Wireless is much more common to us, right? 3G, LTE, and those type of technologies. Explain how different kinds of networks, LAN, WAN, why they're a network, WLAN, WWWAN, WWAN are connected, how communication works in each. LAN, what is LAN? LAN이 뭐지? 일반적으로? LAN cable. 유선 인터넷 많이 하죠? LAN. 이거 what is the name for this? What do you guys call this cable? 뭐라 불러요? 인터넷선. 진짜? 인터넷선이라 불러요? 이거 인터넷선이라 불러요? 안 돼. 공대생은 인터넷선이라고 부르면 안 돼요. 이거 뭐 typically they say Ethernet cable, Ethernet cable이라고 안 불러요? Ethernet cable or LAN line, LAN cable 많이 이렇게 부르는데. Ethernet is also a protocol name too. So we use this every single day, but don't call this as an internet cable, please. 그렇게 부르지 마. 뭐 after this course you can call it differently. 아 이거 인터넷 케이블이라고 그러는구나. 뭐 그럴 수도 있지. 우리 어머니 아버지도 랜 케이블이라 그러는데 인터넷 케이블이 뭐야? 그러면 안 돼요. So how the cables transfer those different type of protocols there. Explain the importance of the standard and protocols communication among computing devices. I'm usually very surprised to hear that. when you guys buy a 공유기 네트워크 뭐냐 무선 공유기, 무선 공유기 especially. What are you usually looking for when you try to choose one of them? 뭘 보고 사요? 공유기 사면? 공유기 사면 뭘 보고 사지? 가격? Pricing? Probably. But yeah, pricing probably first. And then usually they're looking for speed, right? If you try to buy, they usually say, 막 이렇게 적어놨잖아. Up to 300 megabits per second, megabps. Well, if you buy a bit cheaper ones, the speed is maybe down to 100. 야, 전혀 대화가 안 되는구나 이거 지금. 그죠? If you look at the box, they usually say if it's a Wi-Fi device, it's Wi-Fi. But our 공유기, our sharing device can support N, G, 뭐 B, C 이렇게 안 해? 이런 거 본 사람 선전할 때 니네 정말 큰일 나겠구나, 그죠? 이럴 때는 어디로 들어가면 좋아요? 애누리닷컴으로 들어가면 최고예요. 보여줄게. 왜 좋냐? 최고거든. 애누리가 최고예요. 공유기 여기 있다. 공유기, 유무선 공유기, 무선 공유기, AP. Do you know why they call it as a AP? AP라고 자주 부르는데 AP가 무슨 뜻이에요? 혹시 아는 사람? Access Point. 우와. 이게 짱이다. 이게 상상을 초월한다, 야. 어? 여기 보면 한국말로 이거 할게. 여기 보면 우리 제일 많이 싸고 있는 게 IP 타임 뭐 이런 거 많이 사잖아. 이렇게 보면 여기 무선랜 N 돼 있지. 이게 무슨 뜻인지 궁금해 본 적 한 번도 없어요? 여기 보면 they actually give you nice tables like whatever that means. 802.11n can give you up to speed of 300 megabits per second. This is how much data you can send. It means 300 mbp means megabits per second. 300 메가비트를 초당 보낼 수 있는 최고 속력 나옵니다. And then there is another one says maybe slightly different, says 150 megabits per second. And the small one is 54 megabits per second. But they have all NG, right? NG. So if you take a look at 공유기 carefully, they actually says this 공유기 can support NG. That's how much they can support. That is actually name of the protocol. This is protocol name. 802.11n is the Wi-Fi protocol name. So if that's a brand new protocol, there is also a new protocol called AC, 802.11 AC, which is very fast in terms of speed, right? So these are the protocol numbers. 그래서 아이패드 요즘 거 사는 사람들은 probably they can support up to N. 진짜 최근 거 사는 사람들, iMacBook이나 최근 거 사는 사람은 뭐 up to AC. They can support up to AC. It means they can support that protocols. So that's actually protocol names that we use. 802.11n, 802.11g. Something is missing in front actually. 이 앞에 사실 빠진 게 있어요. 뭘까? 혹시 아는 사람? 여기. IEEE 802.11n is actually the name of the protocol that you can use. So using that protocol, I can communicate to the Wi-Fi point in this room. 이게 한국말 번역하면 무슨 공학자 협회 이래요. 세계 전기 전자공학자 협회. 거기서 만든 표준 프로토콜. 실제로 이렇게 되는 거예요. 이렇게 되는 거예요. 대부분 IEEE 빼놓고 얘기하는 거예요. So that's a brief idea for protocol. So we are using it every day, but you guys not aware of that. AC는 최근에 나온 걸 거예요 아마. AC는 아마 여러분들 컴퓨터들이 아마 AC를 서포트하는 게 많이 없을 거예요. 공유기는 AC들이 슬슬 나와도. 그죠? 이렇게 보면 싸잖아. 150메가 하는 거 좀 싸죠? 300메가 하는 거 좀 비싸고. 그렇게 보면 돼요. So explain importance of the standard protocols. Good example for like IEEE 802.11 variations and communication among the computing devices. 요즘 이런 거 많이 나오잖아. It's a popular terms for Internet of Things. Internet of Things. How is that translate to Korean? IoT 막 이라고 말해요. 사물 인터넷 뭐 이런 얘기 많이 나오잖아요. 신문에 보면. 그렇죠? Name the layers of the protocol hierarchy and describe the purpose of each layer. This is a bit difficult concept, but in order to implement this type of protocols, they use certain concept called layering. I'm gonna explain briefly later. So, demonstrate protocol like DNS, IP, TCP, HTTP. So these are the very common, very popular protocols that you use in your computer every single day. DNS, you probably don't know yet. Okay. But IP, maybe you know. IP는 많이 들어봤죠? How does the IP look like? Yeah, it's a number dot. So, what is the Hanyang University's IP addresses? Hanyang University web server. Well, it starts with 167.144. something. So, that's the IP. IP is shortened for Internet Protocol. Internet Protocol. TCP도 얼핏 들어봤죠, 여기서. TCP, IP 이렇게 많이 얘기하잖아요, right? So that's actually in two different layers, two different protocols. Use it together. And HTTP, I'm sure you can use it. So your web browser, Internet Explorer, Safari, or Chrome, is a program that uses a HTTP function in it. So hopefully we can take a look at a little bit. Explain how the existence of the internet has led to a new mode of the communication such as email. 이메일이 new mode인가? It's an old mode of communication, research sharing, and e-commerce. Things like cloud, Amazon. Like, describe the highlight of the history of the internet web. Explain how the modern system came into being. 이건 뭐 histories. I usually don't care too much about histories, but some general concept in it. Okay. So in the introduction, it says computer network has a revolutionary impact. Who's the guy who made the first ever website? He was in Seoul a few weeks ago. 세계 최초의 웹사이트가 뭐지? HTTP? 네이버. 머리 아파. 아니야, 네이버 아니야. 절대 아닙니다. 나중에 알파넷은 인터넷의 시초예요. 인터넷 시초. 웹사이트랑 인터넷 조금 틀리죠, 그죠? 알파넷 좀 더 나옵니다. 달파, 알파넷 나오는데 좀 더 나옵니다. 맞아요, 알파넷도 맞는 얘기인데. 인터넷, the guy named Tim Berners-Lee, he made the first ever HTTP website. 그죠? When he was working for CERN, 그 왜 유럽에 스위스에 가면 뭐 이렇게 동그랗게 레이저 빙빙 도는데 레이저가 아니라 뭐라 그러니? 그 엑셀레이터 그 이제 광속계 하는 데 있죠? 거기 일하다가 물리학 하시는 분이 만들었어요. 몇 주 전에 한국에 와서 서울에 와서 막 연설도 하고 그랬는데. So he made the first ever website. So if you type it up, Tim Berners-Lee's first website, you can access them at this point too. It's very stupid looking, very text-based website, but that's revolutionary approaches. Electronic commerce. I'm not the commerce guy, but things that you can buy from the internet, I guess it's all there. Worldwide communication, spread of information and data. We take it for granted, access to information on any subject, immediate contact with the people around the world, blah, 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 streaming audio and video, YouTube, neighbor video. Anybody use a Skype with your friends? FaceTime 하는 사람 혹시? Anybody use a FaceTime? 한번 해봤어요? 그냥 보이스, 그냥 LTE로 많이 하지. 화상전화 하는 사람 있어요? 화상전화 잘 안 하는구나. 뭐 하는 게 뭐니? 게임은 많이 해요? Wired and wireless access from every devices. Basic networking concept. Computer network made up of computing devices, node, and interconnections. So computer network. What is a network? Network. You're connecting your computer to someone else's computer. To be more exact, you're connecting between two processes. You're connecting program to program. So process in your computer, in the memory that we discussed, the process within your memory can talk to some other process in someone else's computer memory. So how is that possible? So if you extend that more, that's going to be an internet. So usually computer networking course comes after the operating systems. OS라는 과목이 있어요. Operating system. OS 그 윈도우 뭐 이렇게 기본적인 개념 나오고요. Usually computer networks comes after the operating system because in the operating system they give you concept for process, programming, how to do it within your memory. And then networks will teach you, not teach, but extend the idea of process, inter-process communication. Process to communications. 근데 뭐 요즘엔 인터넷 이렇게 많이 써버리죠. Network may be wired and wireless, LTE, 3G, and 아니면 line, 이거 뭐 인터넷 케이블, Ethernet cables and stuff. Wired, dial-up, and broadband modems. 24. The first modem that I used when I was 몇 살이야? Elementary, so 10, 8. Modem was 얼마였더라? 5.6K, 25.6 kilobits per second. Very slow modems. It takes about a couple hours to download a maybe 1 mega file image. 그랬었어요. Later the modems were better. Then it becomes like 128K, 256K. Then at that point that you can start using that modem as play StarCraft with your friends. 그때는 모뎀으로 연결해갖고 스타크래프트 하고 중간에 막 들면 전화 끊기고 그래가지고 막 그랬던 것 같아요. And then it goes to a broadband DSLs that we know, but usually marketing terminologies. Wireless LAN, Wi-Fi is a good example for that. 3G was there. Also, you guys know for 뭐냐? 3G 중간에 있던 거, 혹시 이름 기억하는 사람? Wireless LAN. Vibro, 그죠? Anybody has a Vibro egg? Anybody using that? egg 아직 쓰는 사람 혹시? 썼었어요? Vibro 썼었죠. Was it good? A lot of people still using a Vibro egg because it's cheaper now, but it's supposed to be a competing technology against the LTE. 원래 뭐 우리나라는 와이브로 표준 싸움하고 와이브로를 막 밀려고 그랬는데 결국엔 LTE한테 당했죠. 원래 와이브로가 나왔을 때만 해도 LTE는 유럽 쪽에서 나온 표준이에요. LTE는 유럽 쪽에서 나온 표준인데 원래 그때만 해도 LTE는 아무것도 없었어요. 근데 2, 3년 만에 따라잡아갖고 거꾸로 역전됐죠. 왜 LTE가 역전됐을까? 왜 와이브로 안 쓰고 우리 LTE 쓸까? 왜 그럴까? 그러게 차이가 뭘까? 프로토콜은 일단 틀려요. 표준이 틀리는데 근데 LTE는 예를 들면 와이브로로 LTE만큼 하게 하려면 안테나 지하철역 가면 안테나 엄청 많잖아. 다 숨겨져 있어요. 우리도 이 빌딩 꼭대기에 보면 안테나 많이 달려져 있죠. 3G LTE 하려고 많이 달려 있어요. 옥상의 꼭대기에. 근데 와이브로는 그렇게 하려면 안테나를 다 바꿔 달아야 됐어요. 기술이 틀려서. 근데 LTE는 기존에 쓰던 2G, 3G 이런 안테나를 조금만 고쳐줬으면 그대로 쓸 수 있었어요. 그래서 안테나만 안 달면 비용이 얼마나 줄어. 구축하는 데 돈이 좀 덜 들고 그리고 뭐 전략적으로 좀 밀고 그랬죠. 기술적인 차이? 뭐 그런 게 있지? 와이브로는 처음에 와이브로 1 이런 거는 뭐 그렇게 했을 거야. 60km로 이동하는 차 안에서 뭐 10메가, 5메가 다운받을 수 있게. 실제는 60km보다 120km까지도 됐었어요. 근데 그 당시에 그렇게 돼도 60km라고 설명을 하긴 했었어요. 그만큼 투자를 많이 해야 돼서. 와이브로 우리나라에서 와이브로 투자한 큰 회사 2개 이름 뭔지 혹시 아는 사람? KT도 맞죠? KT도 맞는데 장비에 투자 많이 하는 회사 혹시 알아요? 맞아요. 삼성이 하나 있고 막 찍어. 뭐 삼성 아니면 LG겠지 하고 막 찍는 거죠. 저거는 뭐 뒷걸음치다 그 정도 수준도 아니에요. 그냥 찍은 거예요, 저거. 한 군데가 더 있었어요. 포스데이터 옛날에. 지금 포스코 ICT라고 그러죠. 걔네가 거기 와이브로 장비 투자한 게 얼마인 줄 알아요? 한 2조 5천 원인가 투자했었어요. 2조 5천 원. 그리고 한 2, 3년 전에 손 털고 나왔어요. 이제 더 이상 못 한다 그래갖고 털고 나왔어요. 삼성도 그 정도 더 투자했죠. 몇 조 투자했는데 그냥 명맥만 유지하고 있죠. 포스코 ICT에 다니는 사람들 이제 다 어디 가는지 모르겠어요. 와이브로는 우리 이름이고 실제는 와이브로 원래 이름, 원래 프로토콜 표준 이름 혹시 뭔지 아는 사람? YMAX라고 그래요. 외국에서 YMAX. 이거 the protocol name is IEEE 802.16. 이 와이브로 YMAX protocol 이름이에요. So you can, if you looking for documentation under this name, then you can find the Vibro standard protocol names out there. 이게 뭐 기술이 뛰어나서 꼭 살아남는 건 아니고, 꼭 뭐 좋은 기술이 살아남는 건 아니고, 마케팅도 잘하고 막 편하고 전체적으로 비용이 많이 덜 들고 하는 게 살아남는 거니까 꼭 와이브로가 기술이 후져갖고 실패한 건 아니고요. LTE가 그냥 바람을 타다 보니까. LTE 막 이렇게 선전했잖아. 뭐 4G 막 이렇게 선전했잖아요. 그죠? 사실 4G란 말은 존재하지 않아요. 3G, Third Generation, Fourth Generation. Third Generation, Fourth Generation이랑 다른 점이 뭐가 있어요? 그냥 마케팅이야 사실. 비즈니스 마케팅이에요. 요즘에 또 나오는 거 있는데 그 다음 뭐야? 요즘에 신문 보면 슬슬 5G라고 나와요. Anyway, that was a gibberish. I didn't care. Let me finish up to this slide and I will let you go. So this part was briefly explained in the previous chapters, right? We all want a digitized data sets, but how to send a digitized data on top of this analog signal, like your telephone lines, modems. So telephone line is not digital; it's all analog signal. So you kind of put this on top of this analog signal. 여기에다가 대충 실어 보내는 거예요. So how to put this on top of here is a modularization technologies. Depends on how good they are, the speed increase. Actually, next slide shows you this. 이게 analog signal that you can send. This is digital data from your computer. You actually combine it like this. 그러니까 얼핏 비슷하게 1, 0, 1, 0 using that signals. 이게 modularization technology better 그러면은 더 짧은 시그널에 0101을 더 많이 실을 수 있으면 데이터가 더 빨리 가는 거예요. 그래서 modems it goes to 15, 16K, 15.6, 255 계속 늘어났죠. 그렇죠? 이게 좋아지는 이 기술이 좋아지는 거예요. 그 아날로그 시그널 위에다가 디지털 시그널 위에다 없는 기술이 좋아지는 거예요. 비슷해. 와이파이도 N이 좋고 뭐 B가 좋고 하는 것도 비슷해요. So analog lines transmit the digital data. Modems that we have, it's actually modulate carrier wave. So we put this on top of analog. This is what modem is doing. We still have modems in our home. They're actually doing that every single time. Speed up to 56 kilobits per second. This is all type of modems. Bandwidth, it's capacity. What is bandwidth? Like I mentioned in the TV commercials for your LTE phones, they usually say, my phone can reach up to 300 megabits per second, which is good enough to watch YouTube in the subways. 그죠? 대역폭 bandwidth. That's usually the targeting point. I don't know how much bandwidth that you can have in your smartphones. 여기서 다운받으면 얼마나 나올까? LTE로. What is the maximum speed that you can download on your LTE phones in this classroom? I don't know. I haven't tried. But probably less than a megabyte. I don't know. Megabytes. If you're lucky, 1 megabits per second. Otherwise, usually less than that. 어디 딴 나라 같은 데 가면 그런 경우도 있어요. 스피드를 500K 정도만 주고요. 돈을 싸게 받아. 500K 정도만 주고. 그러니까 500K면 일반적으로 선전할 때 500K 그러면 실제로 내가 갖는 건 아마 100K 정도밖에 안 될 거야. 운이 좋아야. 지금 여러분들 쓰는 LTE도 뭐 10메가 뭐 이렇게 얘기하는데 운이 좋아야 1메가, 나쁘면 그 아래죠. 그죠? 한 500-600kbps per second 하니까. 그죠? 그렇게 돈을 좀 적게 받고 싸게 하고 그러는 경우도 있어요. 대신에 무제한으로 쓰고 뭐 그런 것도 있어요. 우리나라는 조금 그런 게 없는데. So you can think of that as a capacity, as a bandwidth that you can try. Maybe next class I can bring up some of the website. They measure this type of bandwidth for every country. 맨날 나오잖아. OECD also do a survey on how much bandwidth on a single the internet connection can you have each countries. 매년 나오는 거 있지. 어느 나라가 인터넷 스피드가 제일 빠르냐 하는 거. That they use a bandwidth to measure the speed of the internet. Okay. 여기까지만 하자. Well, I'm gonna stop here today, and I will collect your assignment after this. 일단은 any questions for today?